2. That's the qualitative. Then after that, they will now go over the question 1 again. Okay. Okay. So some other students too, they join us in this. So we'll run through the question 2. Then those who missed yesterday will stay back for a makeup of question 1. Okay. So yeah, that's it. Okay. Sean, you're welcome. You're welcome on board. So we'll look quickly at the question 2. Of course, for your question 2, that's your qualitative analysis. Okay. And for the qualitative analysis, it just takes you having an understanding of the basic concepts of testing for cation, testing for anions, testing for gases, okay, and using litmus paper, okay, using litmus paper to test and recording your observation. It is very important that you are able to record your observation. After making observation, you must be able to record observation. Then in recording your observation too, you must be able to make necessary inference. You must be able to infer. Inferring means that you must be able to tell us what you have seen so far. That is the meaning of making inference. You should be able to tell what you have seen so far based on the experiments that you have performed. Okay, so those are the things that I'll be taking you through this morning. Let me share my screen with you quickly. If you can see my screen, just let me know. Can you see my screen?
Yes, sir.
Okay. So I'm going to start with this, but before then, so let me talk you through the materials that I will send to you. Okay, so I'm going to be sending you this. Okay, now for this particular material, if you click on these links, okay, it will take you to the video that explains each of these. Maybe how to add indicator, how to fill your burette, how to handle titration apparatus, how to carry out your first titer and second titer, how to do your calculation. Then these videos will be on how to carry out your calculations, calculating percentage purity, calculating molar concentration and titer value. They are carefully explained video that will definitely help you. Okay, and this later part, it's the session for yesterday is a recap video for the session of yesterday. It's there, so it's about a 2 hours video. Okay, so you can watch that. So I'll be sending this to your WhatsApp later. I think she already has this. Okay, so in there too, I'll be sending this to you too. Okay, so let's go on straight to this particular qualitative analysis. Okay, so can you hear me, please?
Yes, sir.
Okay, so for your qualitative analysis, if you have questions set for you, they will give you questions like this. Okay, they will set questions like this for you. Usually it will be question 2, AI, and stuff like that. They will give you questions like this, and it will now let for you to take the questions and carry out the tests, okay, that is written, or the tests that are written in the question paper. So the first thing you need to do is to check your table, okay? Check your table properly, whether you have all the materials that you need for your test. So when you go through the questions, okay, so this is a sample question, for example, okay? They told you that you are provided with XC, an organic substance, and XD, an inorganic solid. Carry out the following exercises on XC and XD. Okay, those are samples. record your observations, and identify any gases involved. State the conclusion drawn from the result of each test. So what that simply means is that you are going to draw a table. When you get your question paper, the next thing you do, you're going to draw a table of tests, observation, and what? Inferences. Test, observation, and inferences. This is what your table will look like. Test, observation, and what? And inferences. Okay. Now for your test, what are the things you are going to write in the column for the test? Okay, so you go back to your question. You go back to the question, and from the question itself, you'll get your test. Like this particular one says, describe the appearance and odor and pH of what? Of sample X. Okay, so your 2A, that's the first thing you are writing there, will be something like this. Okay, sample. Okay, I'm sure you can see the things I'm typing. I want to take you through it gradually together. Okay, sample X, sample XD, that should be XD. So you get that for your question. Okay, XC first, sample XC. Okay, then plus, if you like, they say you should what? Find the appearance of what? Sample X, or sample, let me just call it sample C. Find the appearance of sample C. Okay, so you're looking for the appearance. Okay, appearance of sample C. And what else are you supposed to do with sample C from the question? What are you supposed to do? This is the question. Tell me the next thing you're supposed to do.
Describe the appearance of sample.
Okay, appearance, yes. And what's the second thing? On the slide, that is A part. Describe the appearance. Describe what else? The odor and the pH of sample C. Okay, that's it. Can you see that? Okay, so yeah, so then we'll describe that. Then we'll go to, that means you are describing the odor. Okay, the odor. Okay, then the third thing is that you are describing the what? The pH. Okay, you are describing the pH of what? Of the sample. You are describing the pH of the sample. Okay, let me admit Fatima Amar. Okay, they're coming in. Okay, so can you see that? That's how you write it, please, very neatly. These are the three things. Then you go to your observation. You go to your observation. In your observation, you're going to take that sample that you have. You know, X is, they said it's an organic liquid. Okay, it will be in a boiling tube, or you take it from your reagent bottle and pour it into your what? Into your boiling tube. Okay, so now I will just show you how sample X, okay, or sample C will look like, so that you now tell me the what? The appearance of what? Of the sample. Okay, so that you tell me the appearance of the sample. Okay, good. So what we are doing now is we are describing the what? The appearance, right? We are describing the appearance of the samples. Okay, so look at this. Look at this. This is your sample. This is your sample D, and this is your sample C. Okay, so this is your sample D. Okay, and this is your sample what? Sample C. So who will tell me the appearance of sample C? Can you tell me the appearance of this sample C? How will you describe this? You are holding it in the boiling tube or in the test tube. You are holding it in the test tube. Can you describe the appearance of this sample C? Yes, someone should describe for me.
It's in a liquid form.
Okay, brilliant. Sample C is liquid. Yes, you know, we are describing the appearance now. Okay, they already told you that it's an organic liquid, organic substance, right? So it's a liquid, that's an appearance. So what other appearance can you give? Or what other appearance can you give? Yes, Indatu said it's a liquid, right? Brilliant. That's fantastic. Okay, it's clear. So you use the word color what? Colorless, clear, liquid, colorless clear what liquid. Now, I need to quickly tell you something there. It is possible for a liquid to be colored, okay, and be clear. Yeah, it is possible for a liquid to be colored and be what? And be clear. Okay, so an example, if you look at this, I have 4 liquids in the test tube here. 4 liquids in the test tube. Okay, the first one here, A, this A is colored, but it is not clear. A is colored, but what? But not clear, right? But B, okay, this is B. B is also colored. It's like, what's the color of B there? Can you describe the color of B? Who wants to describe the color of B?
Oh, yellow.
Okay, light
clear.
Yellow. So you can see that it's pale yellow, but to some extent, I can still see through it. So, but C, this particular C, sample C that you have, it's what? It's colorless and what? Clear, so liquid. Okay, colorless and clear liquid. So let's go back to the table of results. So the moment you get your question, the first thing is draw your table of what? Result. You have your test, you have your observation, and you have your what? Inference. Your inference simply means that you are concluding, so to say. Okay, so this is the table of results you are working on. So we have seen that sample C is what? Excuse me. Sample C is what? Is a colorless what? So you write it down there. Okay, colorless. So as I'm typing to you to be making your own notes, be making your notes there. Draw your table, your notes, and be making your notes and work along with me. Okay. So get your own notebook and be writing down your observation too as you're working together. Okay. So we have colorless, the colorless, clear, what? Liquid. Good. That is appearance. So what else were we asked to do apart from appearance? The odor. Okay, the odor. How do you think alcohol smell? Okay, so odor. Okay, so the liquid has a spirit smell. Okay, like methylated spirit, smells like methylated what? Methylated spirit. Okay, so what else can we say about the what? About the pH of what? Of this particular what? Particular solution. That's what we want to look at now. Okay. So in talking about the pH of the solution, you want to tell me what pH is and give me 2 examples of substances and their pH. 2 examples of substances and their pH. Yes, who want to tell me? Give me 2 examples of substances and their pH. Quickly.
Sorry, sir, come again.
Give me 2 examples of substances, of any substances and their pH.
Water 7, around neutral.
Okay, water is what? Is 7. Okay. Water is 7. Yeah, that's cool. Okay. Yes, any other substance? Any other substance?
Yes.
Yes, any other substance that has an its pH. Okay, so let's just talk straight about the pH of this particular propan 1 ore. Okay, so we have said that it's a colorless what? It's a colorless liquid, and our focus would be to talk about the what? The the pH of the solution of this alcohol that we have. Okay, so you wouldn't expect that your alcohol would be acidic substances, right? You wouldn't expect that it to be an acidic acidic substance. So if you go back, so let me quickly admit some people into into the room. Okay, so good. Some people are joining now. Good. So let's write that smell, and the pH of that particular solution will be a neutral pH, like what Indatu just said, okay, and has a pH, or you can say you are testing the pH if you are using universal indicator paper. Hope you know what a universal indicator paper is. Universal indicator paper will give you the pH of the solution, okay, but if you are using your litmus paper, okay, it's going to be give you a neutral a neutral color change, okay, it's going to be neutral basically, okay. So, and that tells you that it has a what? It has a neutral pH, okay. That's a neutral pH, okay. Okay, or how do you know that? You may want to write, say, no change to litmus, okay, no change to litmus. So that tells you that the substance is a neutral substance, okay. It tells you that it's a neutral what? A neutral substance, okay. So your inference, what can you infer from this particular substance? Because it has a what? It has a smell. It has a spirit smell. Yeah. So I want to be sure that you are writing your notes, everyone. Do you have your notes with you?
Mm-hmm. Yes.
Okay, please get your notes, do your own table, and be writing your test, observation, and your word and your inference. Okay, so we can infer from this that it's a what? It's a neutral liquid, but we can't tell more about that. It's a neutral liquid, okay? It's a neutral liquid. That's what we can say for now, okay? So now let's go back to the question. So we have looked at question A. We have looked at question A, and question A told us to what? To describe. So question A told us to describe the appearance, and we have done that. Now let's move on to question B. I hope no one has question on the first part that we just did. Now A, if you have a question, please quickly ask your question. Quickly ask your question so that we can move fast. We have a lot to cover. Any question, please, on that first part?
No, sir, no question.
Okay. Okay, so for those that just joined us now, we are looking at qualitative analysis. Okay, qualitative analysis, and then we are actually looking at how to move from the question that you are giving to writing down your table of results, okay, and actually filling the table of results, okay. So we said that if you are giving a question like this, okay, so all you need to do is, the first thing you need to do is to get your table of what? Your table of results. And your table of results, this is your question 2. For your table of results, you have your test, your observation, and what? And inference. Your test, observation, and what? And inference, okay? So your tests, what are the things that will fill your test? Your test will be filled from your question, okay? So you go back to the question that you have, then from every statement in the question, from the statement in the question, you are going to have your what? You are going to have your test. From statement, you are going to have your test. So here, an example 1, I'm going back to the question now. So from the question, it says, describe the appearance, odor, and pH of the sample. So I will go back to my table. That is the first thing. Okay, the first column here, you will take it from the question, but you're not going to write it down verbatim. There is a way you phrase it. Okay, so if you look at the question here, it says, describe the appearance. So I go back to my table and say sample C, or sample XC, what sample D, sample E, whatever name they call the sample, plus the test. The test you have to carry out, you write it like in form of plus appearance, odor, plus pH. to what? To check the appearance and what, and the pH of what, of the liquid given to me. So we have looked at the appearance of the liquid. Okay, so this is how the liquid looks like. Okay, that's what we are comparing. This is the appearance of what, of your liquid. Okay, so we said the liquid will look like this. You can see that liquid in the test tube. Okay, they will describe it. We're able to describe that particular liquid. Okay, so we are going to move on to B. The B part says describe the appearance of sample D. Sample D. Okay, so let's look at this sample D. You are giving this sample, okay, on your table in the laboratory. Okay, you have your table set up for your experiment in the laboratory. In the laboratory, you have your table set up and you are giving this particular sample. Can somebody describe this sample to me? Can you describe that sample? Someone, what does it look like? Yes, who is D? Sample D. Yes, please. You said?
Black crystal.
Okay, it's a black crystal. Okay, it's a black crystal. Okay, so you can see black crystal, you say it's a black what? It's a black solid. But if you see this, you'll be able to tell actually that it's a black crystal. Okay, so we'll say dark brown crystal, as long as you have that darkness. Okay, it's a black crystal. Okay, then if you look at that sample, you did properly in the laboratory, it gives you this kind of sublime nature. You will see something like purple around it. If you look at this Petri dish, you are seeing art now. That is something you will see. It looks as if it is stained with some brown vapor. Okay, so that gives you an idea that this substance is what? This substance is one that sublimes. Okay, it's one that sublimes. So it's a dark wall, it's a black crystal. Okay, so let's go to our table. Let's go up to our table. So we are looking at question 2B now. Okay, describe the appearance of sample D. So we want to describe the appearance of sample D. So you're going to write 2B. Please write in your notes too. Sample D, make sure you are writing. Okay, sample D, sample XD, okay, plus appearance. That's what we are looking at for. We're looking at for the appearance of that sample. So what am I going to write as my observation? Okay, from what Ida suggested, she said that it's a what? It's a sample C, it's a black. Okay, so you may want to write your sentences properly. Sample D is a black what? Is a black crystalline solid. Okay, it's a black crystalline what? Crystalline solid. Okay, that sublimes to give some, okay, proper vapor. Okay, yeah, you will see that. Okay, if you see that Petri dish, you see that stain. If it was given to you on a filter paper in your own lab, if they serve it on a filter paper, you will see that purple vapor staining the filter paper. If it was given to you in a bottle, you will see that brown vapor, okay, staining that bottle. Okay, so it's a black crystal that sublimes. What inference can we give to this? We want to suspect, okay, iodine suspected. Okay, you are suspecting now. You cannot confirm, please. You are suspecting at this level, you are at the level of suspecting. Iodine suspected. Okay, any other crystal that you know that sublime that is black crystal. Okay, so if there's any other one, so that's the main crystal that we know that's sublime. So we are suspecting is iodine. So we want to carry out for that test before we can say that it is what? It's iodine. Okay. Are you with me, everybody?
Yes, sir.
Okay, so that's we are taking that question B. Okay, question B. Okay, so if you follow this procedure, you can actually score all your marks. Okay, under your qualitative analysis. Okay, so if you look at the next thing, it says to a part of sample D. So when you are giving your sample in the laboratory, please don't waste everything. Just be taking a little part at a time for each of the tests, okay? So he said to a part. They may tell you in your question that you should divide it into 3 parts or into 4 parts. Okay, we really can't tell for now, but we know that you are going to use them in parts. Okay, so to a part of sample D in the test tube, add tell me of what? Of distilled what? Distilled water and what? And shake. Okay, add tell me of distilled water and what? And shake. Now, so if we want to test the solubility of these 2 substances, that's what we want to test now. Solubility of what? Of the 2 substances. So I will look at C and D together, and I will show you how it looks like practically. Okay, sample. We are looking at C and D. So C says you should dissolve D in what? In water. Okay, dissolve D in what? In C says you dissolve D in what? In water. Okay, and so let's look at C, D, and what? And E. They are basically about what? About the solubility. They're basically about solubility. So you want to test whether sample D is soluble in water or what? Or not. That's what we want to look at now, whether it's soluble in water or not. Okay, so I will show you the solubility of sample D in alcohol. Okay, so if you look at E, E says to another part of D in a test tube, add about what? About 5 ml sample of XC and shake. So I need to talk you through first some rudiments before we can be able to tackle and understand this particular problem. You need some theoretical background. So I will take you through solubility. I will take you through Iodoform test. Okay, then I will take you through the oxidation of what? Of alcohol. When you have to oxidize alcohol, how that will actually look like. I'll take you through that now. Okay, so let's look at solubility first. Solubility. From your theoretical background, you know that iodine, okay, iodine is an inorganic solvent. Iodine, okay, iodine is what? Is an inorganic what? Organic elements. Yes, that's the right word. Inorganic element, that's iodine. Now, if you dissolve iodine in water, so we are looking at 2 things now, which they could ask you to do. You can dissolve iodine in water, or you dissolve iodine in alcohol. This alcohol represents what? Organic solvent. The alcohol represents what? Organic what? Solvent. So if you dissolve iodine in what? In water, do you think it will dissolve? We want to compare the solubility of iodine in water and in alcohol. What do you think will be the difference? Anybody? If you dissolve iodine in water and in alcohol, what will be the difference in solubility? Yes, who want to tell us? Anyone? Okay. Yes, I'm waiting to get your response.
Sorry, sir, can you ask the question again?
Yes, the question I'm saying, the solubility of iodine in water and iodine in alcohol, what do you think will be the difference? We want to describe that. The difference in solubility. The difference in solubility. Does anyone want to describe?
So this next step, we are going to test for what? Solubility.
Do
We want to test for solubility in water. Let's see how soluble it is.
Or do you think that
then to eat to
iodine will dissolve better in water
so it's
than
likely to be
in alcohol? That's what I'm
water.
asking.
It doesn't dissolve. Water. Let's.
Okay. Okay, so let me just try to bail us out here so we can maximize time on this. Okay, so essentially, if you look at that, because iodine is an inorganic solvent, okay, an inorganic element is going to dissolve more in this alcohol than in what? Than in water. Iodine does not dissolve well in water, but it dissolves well in what? In alcohol. Okay, so let me show you just a laboratory solution of what? Of iodine in water, so that you can see that quickly. So let me share my screen with you to show you that. Okay, so I'm sure you can see this. Okay, so we are looking at the solubility of iodine.
Put it in the test tube.
Okay, this is solubility of iodine. We are putting iodine in the test tube now.
This is our water.
Okay, so we want to pour water into the iodine.
We want to test for solubility in water. Let's see how soluble it is in water.
Okay, so now when you pour your water into your iodine, what you do is you have to shake.
See, it's not soluble or spiraling soluble.
Okay, so look
water. It doesn't dissolve.
Okay. Okay, so look at that. Can you see? You will see that your iodine crystal still remains. The iodine crystal remains, okay, in the tube. So that tells you iodine crystal remains in the tube. That tells you that iodine is sparingly soluble in what? In water. That means iodine is slightly soluble in water. Okay, you can see from this. Iodine is slightly soluble in what? In water. So what you do basically, that's your setup. Pour your iodine, okay,
water
in your test tube. You can see iodine is in the test tube. Then you add what? You add water to that. Okay, so you add water to it and shake.
In water.
Okay, so you add water to it and shake. Then when you shake, you have to look at the level of what? Of iodine. Is it dissolving? If it was dissolving, everything should look as if it appears. But you can still see that we have iodine crystal inside the tube. It means that it's just slightly slightly soluble in what? In water. Okay, so now the solubility of iodine in, let's look at solubility of iodine in alcohol. Okay, so we'll now compare the two together. Solubility of iodine in alcohol. So let's look at this. Let's look at this and compare. So this is alcohol in a tube, okay? And this is your sample C. You can see that sample C is very clear. Sample C is clear. This is your sample C. So we want to pour iodine into sample C, and we'll compare the solubility. You have seen that laboratory work where iodine was dissolved in water and it was sparingly soluble. So let's look at this now and we'll compare the solubility. Okay. So I need to look at it. I will pour iodine crystal inside this tube. So you see whether we have quantity of iodine left. So we are pouring iodine crystal into the tube, okay, gradually. Okay, so you can see the iodine crystal at the bottom. You can see as you are pouring the crystal, if you look at it properly, the crystal is dissolving. It's not gathering at the bottom of your tube. That is how you know. So as this crystal is being poured inside the iodine, you can see that it's dissolving gradually. Okay, so that's how to tell whether a substance is soluble or not. So if it was not going to be soluble, then it will gather at the bottom as as solid crystal. So then you can say that it is insoluble. Okay, so you can see here comparing the two laboratory work that iodine dissolves more in alcohol than in water. So we can see now I'm stirring it together. Okay, compared to the first one, can you see this? Can you see crystal inside? There, I also want to respond. Can you see crystal of iodine inside this after stirring?
No.
No. So that means that iodine is soluble. That is the meaning of solubility. Iodine is soluble in in this particular liquid. Okay. So if in case the question is phrased in such a way that you have to add your sample D into sample C, this is what you are going to get. Okay, if you put your sample D in your sample C, this is exactly what you are going to get. Your sample D will dissolve in what? In sample C. Okay, but I'm just taking you through the theoretical background first. The alcohol can dissolve your what? Your iodine. Alcohol can dissolve your what? Your iodine. Okay, very well. But your water cannot dissolve your what? Your iodine. Okay. So let's now go on to the next thing. We have looked at solubility now. So if you put the two together in your test tube rack, this is something you may want to watch to get. Okay, you can see this first one here. This is my iodine crystal. Okay, this is my iodine crystal here in this particular tube. Can you see? I can see the crystal still in the tube. It means that it is not what? It is not soluble. Okay, but if I dissolve my iodine very well, you can see here the iodine has dissolved into this to give me this what? This solution. Okay, so that is solubility. Now, having looked at solubility, I've looked at dissolving iodine in what? In water. Now, let me talk you through iodoform test. This is your confirmatory test for identifying your sample D and your what? And your sample C. Okay, it requires a theoretical background that you need to watch to know. Okay, so what I'm going to do, I need to listen carefully. I will play this laboratory work, okay, to you. Then I will now explain it so that you understand the theory behind it. So when you understand the theory behind this and this laboratory work, we will now go back to fill our table very well. So please, I need you to listen and to be very observant, okay? Let me know if you can hear my voice in the video, okay? So here, what we want to do is that we want to show how your iodoform test is, okay? So let me explain this quickly. When you talk about the iodoform, okay? Iodoform, okay, is a test, okay? Is a test for primary alcohol, and secondary what? Secondary alcohol, okay, with special what? Special features. So you need to know what are these special features, okay? What are the special features? Number one, the special features will mean that before a substance can give you a positive test, before a substance can give you a positive test, okay, that particular substance must possess certain things. For example, I want to believe that you know the types of alcohol that we have. How many types of alcohols do we have? Yes, someone who want to answer. How many types of alcohol do we have? Hello?
Primary, secondary, and tertiary.
Okay, primary, secondary, and tertiary. Thank you. So for your primary alcohol, it means that on the carbon carrying the OH group, okay, on the carbon carrying the OH group, you have at least two hydrogen. Okay, so for iodoform test, any substance that has hydrogen on the carbon carrying the OH group and also has what? A methyl group. Okay, a methyl group on that particular word, carbon, okay, can give us a what? A positive test. So if you look at this alcohol, this is a secondary what? This is a secondary alcohol. And this particular substance, if I'm to name this will be propan what? Propan 2 what? Propan 2-ol. This is a theory behind your work. You understand this. Propan 2-ol. Now let's look at another alcohol, ethanol. Ethanol, this is ethanol. Okay. Ethanol is this. On the carbon carrying the OH, on this carbon carrying the OH, this carbon carrying the OH, ethanol has hydrogen and what? And a methyl group. This is a methyl group. So it means that it will give a positive test with what? With iodine. This particular secondary alcohol, which is propan-2-ol, this one is ethanol. Ethanol. So we can see here that ethanol can give us a positive test with what? With iodine. Then propan-2-ol, can it give us a positive test with iodine? How do we know? Look at the carbon carrying the OH. This is the carbon carrying the OH. The carbon has hydrogen and also has what? A methyl group. So that means it will give us a positive what? A positive test. Okay, so let's look at another alcohol and see whether that alcohol will give us a positive test. So if I have this particular alcohol, yes, this is propan-1-ol. This is propan-1-ol. Okay, H. Go. Let's test whether, excuse me, let's test whether this particular alcohol will give us a positive test with what? With iodine. What is the name of this alcohol? It is called propan. Okay, propan-1 what? 1-ol. Propan-1-ol. You can see the OH group is on the what? The OH group is on the first carbon. So it is propan-1 what? 1-ol. So let's check. The carbon carrying the OH here has hydrogen on it, but does not have a what? A CH3. The best it has is a CH2. Can you see? It has a CH2. So this will give us a what? A positive test with iodine. So a substance that will give you a positive test with iodine, okay, must be one that has what? Hydrogen on the carbon carrying the OH and what? A CH3 group on the carbon carrying the word OH. So that tells us that ethanol and what? And propan-2-ol, as an example here, will form a positive test with what? With iodine. So let's go to the lab and carry out this particular test. So I need you to be observant. This will show you, interestingly, it's about 6 minutes. So I need to watch the laboratory application. Okay, so let's start.
Theoretical background for the formation of triiodomethane.
Can you hear the sound in the video? I want to be sure.
Yes, we can hear it.
Okay, please.
Which is known as the Iodoform test. So I'm going to be requiring sodium hydroxide and iodine, 10% iodine. So I'll be presenting to you 4 samples. I'll be using 4 samples for this particular experiment. Ethanol, I will use propan-1-ol. I will also use an isomer of propan-1-ol, and that is propan-2-ol. And let's look at another organic solvent, butan-1-ol. Okay, so I will also be needing hot water. Okay, so that will serve as my water bath for this particular experiment. Okay, so let's take the first sample, which is ethanol. So I'll take my first sample, ethanol, and I will add some quantity of that ethanol into a fresh boiling tube. Okay, clean, fresh boiling tube. Then the next thing I will add will be my iodine. Okay, the 10% iodine. Okay, so I'm picking that now. I'm adding my 10% iodine to the sample of ethanol that I have in the boiling tube. Okay, so the next reagent that will be required will be the sodium hydroxide. Okay, the 3 reactants must come together: ethanol, aqueous iodine, and sodium hydroxide. So I'll quickly pour this iodine into the ethanol now. Then I will use a syringe to take my sodium hydroxide, and I will pour that gradually into the mixture of ethanol and aqueous iodine that I have. So I also need to quickly mention to you how I formed the aqueous iodine. Aqueous iodine is formed by dissolving your iodine inside potassium iodide. Okay, so that gives you a good solution of what? Of iodine, aqueous iodine. So now let's add, together the sodium hydroxide to the ethanol and the aqueous iodine. So I'm going to add the sodium hydroxide now to the mixture, and I'm going to do that gradually. Okay, it's very important. So while I'm adding it, you'll notice that I'll be shaking my boiling tube. I'll be shaking the boiling tube. Okay, so I'll add gradually, shake the boiling tube, add gradually, shake the boiling tube, add gradually, shake the boiling tube. Of course, that will help the rate of my reaction and my reactant to mix together properly. Okay, so you may wonder, why do I need a water bath? Just warm water around 60 degrees Celsius will be just fine. 60, 65 degrees Celsius will be okay. Okay, so I'm sure you are noticing some color change from that dark brown to a kind of light brown. So it's changing gradually. So you must know the color change you're looking out for. I'm trying to look out for the formation of yellow precipitate. Could be pale yellow precipitate, could be bright yellow precipitate, or whether I have a colorless solution formed. If a colorless solution is formed, it means that it's a negative test. Okay, so but in this case now, you can see the brown color is just disappearing gradually. Okay, so if it's taking time, you may want to use a water bath. Okay, so I'm going to put this into the water bath soon. I'll shake a little bit. If it doesn't change, I'll just put it into the water bath. Okay, good. Let me just put it into the water bath quickly. Then I will observe the formation of the yellow precipitate of the triiodomethane. Okay, so that yellow precipitate form is called a triiodomethane, and that is where this particular experiment got its name from. It's called the Iodoform Test. The Iodoform Test. Okay, you can see that yellow precipitate. Another thing you may need to note is the smell that was assumed out of that boiling tube. That's the antiseptic smell. Okay, you have the smell of Dettol and all that. So that's what we call the antiseptic smell. Okay, so I'll quickly take the second sample now. That is my Propon 1 ore. Okay, so I will add Propon 1 ore into a fresh boiling tube. Okay, you could use a test tube too, whichever one you are provided with. Then I'm going to take iodine. So I think I'll use a syringe, or I just pour my iodine directly from my boiling tube. Maybe I should pour directly from my boiling tube. Okay, so I pour from my boiling tube into the test, into the fresh test tube that I have, or the boiling tube containing my Propon 1 ore and the iodine. So next thing is my sodium hydroxide. Don't forget the way I'm adding my sodium hydroxide. I'm adding it drop wisely. I'm adding the sodium hydroxide in drop. Okay, so adding the sodium hydroxide drop wisely. Just observe the color change. You can see the color is changing. It's getting lighter. Okay, but my focus is whether it's going to form yellow precipitate or it's going to go overboard and form a colorless solution. Okay, so I think this is going to form a colorless solution. It's getting, it's getting away from the yellow precipitate. So I'm going to put it in the water bath to fasten the reaction. Oh, wow. Brilliant. Colorless. You can see. So this is a negative test. Propon 1 ore plus iodine, sodium hydroxide forms a negative test because I do not have the yellow precipitate there. The yellow precipitate indicates what? Yeah, triiodomethane, CHI3, CHI3. So I do not have that. Okay, so let me take the next sample, which will be my Propon 2 ore. Propon 2 ore. Your Propon 2 ore has your OH group on the second carbon. On the second carbon, I'm going to be demonstrating that calculation or structural diagram for you to see that. Okay, so I put in my iodine to Propon 2 ore. You can see the dark brown appearance of the mixture. Now I will add the sodium hydroxide and shake. Add sodium hydroxide and shake. Add sodium hydroxide and shake. Okay, you can see here. Wow. is forming. Wow, this is brilliant. See, the yellow precipitate, light yellow precipitate. Of a light, you can use the word pale yellow precipitate. Okay, so I have the pale yellow solid precipitate form with the antiseptic smell. Just perceive the smell. Okay, that's how to do your smell. You don't take the test tube into your nose. Just use your hand to do some kind of swap of the gas to your nose. Okay, so that forms a positive test. Now let me carry out the test on the last sample of organic solvent, which is butan 1-or. Okay, butan 1-or has the OH group on the first carbon. On the first carbon, it has 4 carbons, so on the first carbon. Okay, so we'll see the implication of that later. So I'm adding my sodium hydroxide now. Don't forget, add it drop wisely and shake. Sodium hydroxide is like the catalyst in this part of the reaction. It's actually serving as apparently an oxidizing agent. Okay, the sodium hydroxide is serving as an oxidizing agent in this particular reaction. Okay, so let's move on and see. I'll put it in a water bath and see what will form. Don't forget, we are looking at for 2 things: formation of yellow precipitate or colorless solution at best. Okay, so if it forms yellow precipitate, it means it's a positive test. If it forms a colorless solution or a colorless mixture or a colorless liquid, it means it's a negative a negative test. I'm kind of having a feeling that this is going to give me a yellow precipitate. But if it doesn't, then it's going to form colorless mixture. So if it's colorless, that's a negative test. Okay, yeah, good. So let's put it in water bath and see what will be formed. Let me add more sodium hydroxide to it to help the reaction move faster. Okay, so the sodium hydroxide, don't forget I said it's like a catalyst, like the oxidizing agent in this reaction. Okay, wow, this is going to form colorless. So let me add more sodium hydroxide. Okay, to that, wow, so that's colorless. I mean, this is brilliant. Okay, that's colorless. So I've added the sodium hydroxide to that's colorless. Okay, good. So you can see now I have my ethanol forming positive test and propan 2-or forming positive test, while my propan 1-or and butan 1-or forms the negative test. Okay, so you may also be asked to filter. Yeah, you may be asked to filter. So my goal is just for you to understand what the iodoform test is. So after carrying out the test, you may be asked to carry out a filtration. Use your filter paper. You may not have this type of filtration apparatus in your laboratory. It may just be your funnel and filter paper. Just filter it, collect your filtrate, yellow filtrate on your filter paper and dry it. Okay, so that's just the simple explanation of the iodoform test. It's very simple to understand. Okay, very, very simple to understand. Okay, thank you.
Okay, quickly. Good. Now, from this, what we have looked at on testing for the iodoform test, and then the requirement for the formation of the iodoform test. Okay, quickly. So in the chat section, quickly, I want you to I'll post a question there now, and I need you to respond back to me. Okay, in the questions for everyone present here. Let me see quickly, how many schools do we have, present here? How many schools do we have present? Yeah, so you may want to just type the name of your school in the chat session. Yeah, for me to see, type the name of your school in the chat session quickly. Just type the name of your school. Do that quickly. Let's do this within 1 minute or so. Put the name of your school in the chat section. Okay, so I'll put questions there in the chat room, and I want you to respond to the question, okay? I want you to respond to the question. As you respond to the question, just put the name of your school, in front of the question. Okay, so based on what we've done so far, quickly. So the question one is list the requirement for the formation of iodoform. List the requirement for the formation of iodoform. Okay. Okay, that's question one. Quickly respond. Question two. What is the formula for iodoform? That's question two. Then question three, we'll make it just three questions. Question three, okay. Can ethanol dissolve iodine crystal? Can ethanol dissolve iodine crystal? Okay, let me get your responses quickly. Yes, send your response in now. Yeah, Hama, Hindatu, Shion, Riskat, send in your response. Yeah, send it in and I'll read it out quickly. Send your response in. Okay, let's be fast with that. Okay, brilliant. Okay, brilliant, Fatima. That's brilliant. Yeah, okay. Good. Oh, this Ibrahim. Okay. Yeah, it's Miss Ibrahim that explained to us the solubility of iodine in water and ethanol. Okay, she was the one in the video that we played. Okay, good. Okay, so let's send in more of your responses quickly. Send in more of your response. Then we can now fill our table. Send in more of your response so that we can be done with the table. Then we'll do a, for those who missed yesterday, I think virtually everybody here missed yesterday. So that is your question one, okay? And it carries a huge part of your marks for the exam. So we'll go over that, okay? I've gotten feedback that the calculations need to be re-explained, okay? So I'll go over that. So but we need to finish up drawing this table. So yes, I need more response in, please. More of your response, send it in, send them in. Send your response in. I've got a response from Fatima. Okay, I'm waiting for others to send in their response. Yeah. Can you guys hear me? Can you hear me?
Yes, sir, we can.
Okay, yeah, send in your response. So can you see the question in the chat room?
Yes, sir.
Yeah. We need to have many activities, well, we have a lot of ground to cover, and I'm looking at the time interval that we have to cover those things. So let's just use the chat room to do the activities quickly. Okay. Yes. I need to be sure that you are getting, you have picked one or two things from the explanation. Your response. Okay. In that too. Are you still online? Sending your. Okay. Yeah, Idris, sending your response. Okay. Yeah, brilliant. Hitherto. That's correct. Okay, that's correct. That's correct. That's correct. Cool. So we have looked at the formation of iodoform. Others have expected your response too. The two responses I got, they are correct. Okay, but that's the response for only question 2. So question 1, what's your response for question 1? Send your response for question 1 too. I think that is very key to this particular test. Okay, the requirement for formation of iodoform. Okay, yeah, and you must also need know substances that form iodoform, so that will help you in making your inference, so that when we're talking later about making our inference, you understand the background from where we are coming from. Okay, good. Okay, so can you answer question 1? Answer question 1 too. Let's try to be engaging so that we can maximize the time, okay, that we are using online, and of course the data that is going. Okay, good. Okay, thank you, Hidatu. She said iodine, sodium hydroxide, secondary alcohol with a methyl group. Yes, that's correct. Secondary alcohol and primary alcohol. Okay, with a methyl what? With a methyl group, like ethanol. Ethanol, okay? Ethanol is the only primary alcohol that will form iodoform test, because other primary alcohols don't have what? Don't have the CH or the CH group. So now I think everybody now understands that when you have a colorless substance that has a spirit smell and you carry out iodoform test and it is positive, then you can infer that that substance is what? It's an alcohol. Okay, it's an alcohol. Okay, it's either a primary or a secondary alcohol. So you can make such inference. That is the theoretical background to the to this particular work. Okay, so we have looked at solubility. Yes, thank you, Ida too. She answered all the question there. Okay, good. Yeah, that's brilliant. Ida too, absolutely brilliant. Okay, we can give Ida 2 thumbs up from the chat room there. Just give her thumbs up. Okay, Ida 2 and Fatima. Yeah, please give them thumbs up from the chat elements there. That they had fantastic response. Okay, fantastic response. That's cool. Okay, so she said ethanol can dissolve iodine crystal. So everyone needs to know that. Okay, why water cannot dissolve iodine crystal as much as possible. Okay, yeah, thank you for your responses. So let's move on. So others too, you can be sending in your response as we'll progress. So we have looked at the iodoform test, and I've shown you this practical demonstration. Okay, so another test that you will need to understand would be the oxidation of alcohol. Oxidation of your alcohol. How your alcohol will be oxidized, okay, to either ethanol or to ethanol. Okay, oxidation of alcohol. Okay, so from the example that we have said, Ida told us that we have primary, we have secondary, okay, and we have tertiary alcohol. So she told us that now, so our focus now is oxidation, okay? when you add oxidizing agent will just use this to represent oxidizing agent. And an oxidizing agent that you will be using in this particular experiment is potassium heptaosodichromate 6. Okay, potassium dichromate. That's the oxidizing agent you'll be using. If you add potassium dichromate to a primary alcohol, it's going to oxidize the primary alcohol to alkana, okay, to alkana, then from alkana to what? To carboxylic acid. That is your alkanoic acid. If you do for secondary, okay, alcohol, okay, it's going to oxidize it to what? To alkanone. To alkanone. While your tertiary alcohol cannot be what? Oxidized. Please be notes. Tertiary alcohol cannot be what? Cannot be oxidized. Okay, cannot be oxidized. So the next thing that you need to note here will be your color change, because this is practical. Your color change when you add potassium chromate, okay, potassium chromate to a solution of what? Of your primary alcohol. Okay, your primary alcohol is colorless liquid. That's a colorless liquid. Then you add potassium chromate to it. Okay, we said it's going to get oxidized towards to alkanol or alkanoic acid. But the question is, what is going to happen to your potassium chromate? What's going to happen to your potassium chromate? Your potassium chromate is a yellow, okay, is a yellow a yellow substance. Potassium chromate is a yellow substance. When you add it to your alcohol, your potassium chromate will change color from yellow to green. It will change color from yellow to green. And when it changes color from yellow to green, that tells you that your potassium chromate has been reduced. So in this particular experiment, if you pour your potassium chromate to your sample C and you heat it a little bit, or you put it in your water bath, and the color changes from yellow to green, that tells you that your sample, okay, is what? Is an alcohol. Okay, your sample is a primary or a secondary alcohol. It's a primary or a secondary alcohol. So this is the theory behind the oxidation of alcohol. Okay, so I want somebody to reiterate this, to re-explain this oxidation of alcohol. So let me know if you got the explanation. Oxidation of alcohol. Who want to explain it to us? You can use what's on the slide here to just explain. Oxidation of alcohol. Who want to explain it to us? Yes, someone quickly. Oxidation of alcohol. What do you understand by the oxidation of what? Of your alcohol. What do you understand by the oxidation of your alcohol? Yes, somebody quickly. Yes. Who want to do that for us? Oxidation of alcohol. Yes, I'm listening. Oxidation of alcohol.
Yeah, take an oxidation test for our sample C.
Okay.
We want to take oxidation test for our
Anyone
sample
explaining
C.
that?
So these are sample C.
Yes. Or you want to send it in the chat section in case your audio, maybe you have issues with your audio. You want to send your response in the chat session. I can take it from the chat session. Yes. Quickly, who is saying something? Or you can type in the chat session, what do you understand by the oxidation of alcohol? Oxidation of alcohol based on primary, secondary, and tertiary. Before I show you the laboratory demonstration of that. Yes, or you send me chat in the chat session, I will get it and read it out to everyone. Yes, quickly. before we look at this oxidation. Or have I lost my audio? Can you hear me? Can you hear me? Can you hear me, please? Can anyone hear me?
Yes.
Okay, yeah. Or you want me to re-explain oxidation of alcohol? Do you want me to re-explain the oxidation of alcohol?
Yes.
Okay.
Yes, sir.
Okay, yeah. So as I'm explaining, if you do not understand, you can just speak and stop me at any time and ask me to re-explain, or you send message in the chat room, okay? So you must understand, okay? Yes, thank you, Hilda too. It says primary alcohols can be oxidized to form aldehyde or carboxylic what? Carboxylic acid. Yes, that is alkana or alkanoic what? Acid. Good, primary alcohol. Okay, so, okay, let me re-explain. Let me re-explain oxidation of what? Of alcohol, okay? Now, I will re-explain that, okay? So let me show you the video, okay? Then I will now re-explain. Okay, can you see this video? Can you see this video?
Yes.
Okay, so let's ask Miss okay, so she's going to explain the oxidation of alcohol. Okay, from the oxidation, I'll now tell you the theory behind it to re-explain. So let's listen and watch the change that we can see there. Okay.
Adding to our test tube. Then these are dichromates. Potassium what? Dichromates. So you add it. Okay. So there's a color change that we are expected to see. Take an oxidation test for our sample C. We want to take oxidation test for our sample C. So these are sample C. Adding to our test tube. Then these are dichromates.
Okay, so you can see your sample C. Your sample C is colorless. The sample C is colorless. Okay, good. Sample C is what? Is colorless. But this particular, we are going to add this potassium dichromate. You can see the color of the potassium dichromate. It's like orange. Okay, orange color. So we are going to add the potassium dichromate to the sample what? To the sample C.
Potassium what? Dichromate. So you add it. Okay. So there's a color change that we are expected to see.
So you'll be observing the orange color is turning gradually. Can you see the orange color? It's turning away from
coloration.
orange towards
greenish coloration. That's oxidation. It oxidizes our organic solvents, which is our
you put
alcohol,
that test tube in a water bath, or you warm it gently.
To what?
Okay, you warm it gently. Okay.
Yeah, that's the color from your organic chemistry. What is the expected
the orange color is fading away gradually. The orange color is gradually fading away. Okay, so that color changing from orange to green indicates that what? Indicates that your potassium dichromate has been what? Has been reduced. Okay, so that's what we are saying, that your alcohol, we have three types of alcohol. We have primary alcohol, we have secondary alcohol, and we have what? Tertiary alcohol, right? Okay. Now the primary alcohol can be oxidized, where you add oxidizing agent to it. This represents oxidizing agent in chemistry. Oh, and the oxidizing agent we are using is potassium what? Dichromate. So this potassium dichromate, okay, when you add it to a primary what? Alcohol, you are going to form two things. The first thing will be an aldehyde, okay, which is also known as alkana. alkana, and from there, you are going to form carboxylic what? Acid. It's going to form carboxylic acid. That is the final oxidation, or you call carboxylic acid what? Alkanoic what? Acid. Okay, so it gets to oxidize in 2 steps. Okay, so but for your secondary alcohol, okay, will be oxidized only to ketones, or you call it what? Alkanone. But your tertiary alcohol cannot be what? Oxidized. Okay, so if you add potassium dichromate having a yellow color or orange color to your alcohol, it could be primary or secondary, and the color changes to what? Changes to green or greenish. It may not be entirely like leaf green. Okay, no, it's going to change towards green. Okay, so that tells you that your potassium dichromate has been reduced, okay, in the process of oxidizing your alcohol. Okay, so this formed the theoretical background of your what? Of your experiment. Okay, good. Thank you, Hinda too. She says secondary alcohol can be oxidized to give ketones. Tertiary alcohol cannot be oxidized without breaking the molecules, okay, yeah, into the molecules of the carbon, like breaking it, splitting it into what? Into 2. And we want your substance to be in one piece, your products to be in one piece. Okay, so we have gotten that. Now, we have looked at the theoretical background behind, the theory behind the work, and we have seen the demonstration in the laboratory. So let's now go and fill our table. Please, everyone get your table of results too, and fill it, your test, observation, and results, okay? We're going to just follow through these questions, okay? So however the question is framed or arranged for you in your exam, just make sure you follow the steps given to you, but essentially the questions will be from any of these arrangements that we have here. Okay, so we have looked at appearance. We have looked at what describing the appearance of C and describing the appearance of what? Of D. Okay, so let's go straight to this. Let's say 2C. Let's just say 2C quickly. 2C. Now we want to look at the solubility of sample what? Sample D. Solubility of sample D. So let's say sample D plus water, that is distilled water. Please take your own book and be filling too. Okay, we are doing the test now. I will be writing the test. Then we'll be recalling the observation. So sample D plus what? Plus water. Sample XD, okay, plus water. That your sample D, we looked at it earlier, is a dark what? Crystal, right? So hey, somebody is talking, I can't hear you. Okay, or type your question in the chat room. I will read it out in case your audio is bad. Type your question in the chat room quickly. Sample D plus water, what do you think will be your observation in case you are asked to dissolve your sample D in water? So in case you are asked to dissolve, what do you write? Okay. Okay. Solid is what? Is slightly what? Slightly soluble. Okay, it's slightly soluble or insoluble if you like. It's slightly what? Soluble. Okay, so you tell them that solid, your inference is that solid is insoluble in water. Okay, that's your inference. Solid is insoluble in water. Everybody be writing your table down, be writing it down. Okay, then, so let's look at another test, 2D, test 2D. Okay, test 2D, mixture from 2C. They could ask you to add the mixture from 2C plus, okay, sample C plus about 2 cm3, let's say 2 ml of sample XC. So if you add the mixture in 2C, okay, plus 2 ml of sample C, Okay, you know, we have looked at the fact that your sample C is an organic solvent, right? And you saw that when we dissolve that iodine in what? In your organic solvent, your alcohol, it dissolves. Remember this? When we dissolve the iodine here, it actually what? It actually dissolves, okay? So we need to write down the what? The observation, okay? You need to write down your observation. Sample D in alcohol, it's definitely going to what? Going to dissolve in what? In alcohol. But it will not dissolve in what? It will not dissolve in water. Okay? So please, everybody note that down. Okay? So I want to be sure you have your writing material with you. Those that are just joining us, you are going to do your table of what? Of result. You have your table for test, you have your table for observation, and you have your table for what? For inference. Okay? Table for test, table for observation, and table for what? For inference. Okay? So please note that down. They can phrase the question in so many ways, but we are looking at all the possible ways in which the question can be phrased. So the first thing we looked at was appearance of the two samples. The second thing we look at now is your what? Solubility of your samples. We're looking at solubility of what? Of the samples. Okay. Sorry, my PowerPoint is hanging. Okay. So solubility of the two samples, you would expect that your sample will dissolve in what? In your alcohol. Iodine dissolves better in alcohol than in what? In okay, yes, I will show the table, please. My PowerPoint on because of that video I was trying to play. Okay, so let me bring it up again. Okay, so I will show the table again. Okay, so why the PowerPoint comes up, you can ask questions quickly on what we've done so far in case there is something you do not understand that you want me to go over again. Okay. Sorry, why the PowerPoint comes up quickly, please. Okay. Yeah, just put your question in the chat room quickly. So the moment we finish solubility, we have just 2 more tests, and that will be how to write down your iodoform test and how to write down the table for your what? For your oxidation of alcohol. Okay, that will be the next thing to do. Okay, sorry, my PowerPoint is coming up. Yes. Okay, so let me read question from the chat room. Okay, could you show the table? Okay, good. So somebody is asking during the iodoform test, I will show the table. Somebody is asking during the iodoform test, why do you have to put it in what? Why do you have to put it in water during the iodoform test? Why do you have to put it inside the water? Okay, can you see the table now?
No.
No, sir.
No, sir.
Sorry. Okay. Let me reshare, please. Can you see it now?
Yes, sir.
Okay, so let's do the table. This is very important. Now, somebody said during the iodoform test, where we do it in the laboratory, why do you have to put it in water bath? Now, because the test, sometimes you are doing your test in the laboratory, it appears as if nothing is happening because the rate is very slow. Because this is qualitative test. Okay, examiners will not tell the school the concentration to prepare, except for question 1. So for question 2, if your solution is very dilute, it means that your reaction will not happen very fast. So in case your reaction is slow, and this is exam, you have maybe 1 hour, 15 minutes or 1 hour, 30 minutes. So if you put it in hot water, it will increase the rate of reaction. Please, everybody, hope you are hearing that. Somebody asked that question, and I think it's very important. Thank you, Indatu, for asking that question. When you put your reagents or whatever in the boiling tube, when you heat it directly in the flame or in the water bath, the essence is to increase the rate of what? Of reaction, so that you can quickly see your what? Your test. Okay, so that's the essence of using your what? Your water bath. Okay, good. So I think I've answered your question, right? I think I've been able to answer that question.
Yes, sir.
Okay. So let's proceed quickly to the table. So let's fill up our table of results. So this is the table. So let's just fill it directly. We have seen all the practicals. So let's fill the table now. So in case you are asked to add your sample D, let's say sample D, okay, plus, okay, water, that's distilled water. What should be your observation? Okay, it's tell them that solid is slightly soluble, or you may write insoluble. You still be fine because it really wasn't dissolving. So your inference is that what? Okay, sample D is an what? Insoluble was solid. That is in water. It's insoluble in what? Insoluble in water. Okay, you have to state that. Okay, so now 2D, they could ask you to add. Okay, they could ask you to add about 5 mil of sample C to, okay, mixture to the mixture in 2C. Okay, the mixture in 2C is just your iodine and water. Okay, so if you add 5 mil of your sample C to it, your sample C is an organic solvent, right? It's an alcohol. We have looked at that. Okay, so what do you think your observation will be? Okay, what do you think your observation will be? That was why I was referring you back to this particular test that we carry out. From this video, you were able to see, okay, that what your sample dissolved. Okay, for those who are just joining us, okay, I will try to just play this from the middle. Okay, so this is the test we are trying to carry out now. Okay, oh, I don't want this to hang again. Okay, so your sample would dissolve in the alcohol. It's going to dissolve in the what? In the alcohol. And when it dissolves in the alcohol, it's going to give you a brown solution. So write in your notes now. Write in your notes your observation. Your observation is that the mixture, okay, forms a brown solution, or a pale brown solution. So your inference will be that your sample D dissolve in what? In sample C, or sample D is soluble in sample what? Sample C. Okay, so that is your observation. I say that again. Your observation will be that your what? Your sample, okay, the mixture dissolve in what? The mixture dissolve in your alcohol. Okay, because iodine can dissolve in what? In alcohol. Okay, so your mixture will dissolve in the alcohol. So, but you're not going to be writing alcohol, you're going to be using the word sample. So we are on 2D now. 2D says to the mixture in 2C, add about 5 ml of what? 5 ml of sample C. Okay, so adding 5 ml of sample C, we found out that a brown solution was formed. And that's what is your inference? Your inference is that your sample dissolved the what? Your inference is that your sample dissolved in the what? The sample what? Sample C. That will be the inference that it dissolved in sample what? Sample C. Okay? Cool. So are you done writing that? Okay, have you noted that? If you have noted that, then let me know. Have you noted it?
Noted.
Okay, so my this thing wiped off again. Okay, so we are now in 2E, right? 2E. So 2E, we have looked at solubility, okay, of your sample. So the next thing would be to now carry out your iodoform test. To carry out your iodoform test. But how do you think they might phrase, the question? Like 20 for this part A. Yes, 20. Okay. Okay. Sorry, please. Okay. So let's now go down. So they may ask you for your iodoform test. Okay. They will ask you to put your sample C your sample C in a test tube. Okay, and add your iodine solution to your sample. So they can say sample C or to about 5 ml of sample C, add half spatula of sample D. Okay, so sample C now is your alcohol. Okay, while your sample D is your iodine, but we are going to be calling it sample C and sample D. Okay, so plus half spatula of sample D, then you note your observation. Then after you've done that, then plus what? Aqueous sodium hydroxide. Plus aqueous sodium what? Sodium hydroxide. The moment you see that they ask you to use sodium hydroxide, okay, just know that is the point where you are going to observe your yellow precipitate. It's very important. That's the point we are going to observe your yellow precipitate. So if I add sample C plus sample D, the first thing that I will get will be what? I will get a brown solution formed, which, okay, turns or which forms yellow precipitate with sodium hydroxide okay, with sodium hydroxide. Good. So that will be your observation. It's going to form yellow precipitate with sodium hydroxide. That is your iodoform test. You saw the iodoform test earlier, forming your yellow precipitate. Okay. So, but they could also ask you to warm gently if it's not changing. So in your test, they could say if no change observed, okay, warm the mixture gently. the mixture gently. So you can warm your boiling tube, okay, with your test tube holder on the fire, or you use your water bath. Warm gently, okay. Okay, so you can write your yellow precipitate clearly formed on warming. So that's the observation. Okay, so your inference now, you added a substance that is dark, that is black, solid, to a substance that is an organic solvent. Okay, a substance that is an organic solvent, and you now get a yellow precipitate with sodium hydroxide. Okay, so that tells you something about what? About sample C. So your inference, okay, is that you are suspecting your alcohol suspected. Okay, you are suspecting what? Your alcohol, but you don't know what type of alcohol it is. Okay, so alcohol is what is suspected. And of course, we said earlier that this alcohol could be a primary alcohol or a secondary alcohol with a methyl group. Okay, with a methyl group. So alcohol, okay, with methyl group, okay, on carbon suspected. That's the kind of alcohol that can form iodoform test. Okay, so this particular test could come last, or it could come before the oxidation test. But usually this test 2F might come before your test 2E in the re-exam. Okay, so now we have been able to do your iodoform test. This is your iodoform test 2E. Now, to show that your substance is alcohol, whether it's primary alcohol, secondary alcohol, then let's now carry out tests with what? Oxidation test. So they can also tell you to about 5 ml of sample C in a test tube or boiling tube, if you like. In a boiling tube, add about 5 ml of potassium dichromate. Okay, observe any change. Okay, so they can ask you to warm gently and observe any change. So this test is what they will write in the question. Your test is you pick it from the question paper. So if that is what they ask you to do, so what do you think you will observe? Sample C is an alcohol that I'll show you in the video of the oxidation. When you add it to potassium dichromate, what will you get? Okay, you add that to your what? To your potassium dichromate. Okay, the orange color, that's your observation now. The orange color of the solution change to what? To pale green, or green if you like, to pale green on what? On warming. So when you warm it, it changes to what? To pale green. So what can you now say about that? Okay, so because you know that your potassium chromate is what? Is an oxidizing what? Agent. So you are confirming here that sample C, okay, is a what? Sample C is either a primary alcohol, or what? Or secondary what? Secondary alcohol. You cannot conclude that it is propan-2-ol, please. You cannot conclude. There is no evidence here that is strong enough for you to say it's propan-2-ol. But you can say that it's a primary word alcohol, okay? Because from the beginning, we saw that it was neutral, okay? And it has a spirit smell, antiseptic smell. So we are suspecting that it's what? It's an alcohol, okay? So looking at all these observations, we're able to find out that your sample D is iodine and sample C is what is your alcohol. Okay, good. So this is how your table of results will look like. Okay, so any question before okay, just ask your question as I'm showing this video, just to recap, just like a summary of the tests. So ask your question or things that you need to explain further. Okay, so that's the table. Or if you are done writing this table, let me know. If you are done writing the table, let me know. So you have your 2C. 2C was your sample plus sample D, okay, plus water. Okay, sample D plus water. Okay, yeah. Okay, are you done writing your table? Are you done with the table?
Yes.
It's like the audio is bad. I can't hear you. Just type yes or no in the chat session. So that is the table of your of results. So it is essentially the 2D and 2E are the main this thing there. Okay, they are the main thing in the table. Okay, good. So please go ahead. If you are not done with the table, if you are done with the table, let me know. Okay. 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 So do you understand this table? Hello? This table of results now, do you understand it?
Yes, sir, we do.
Okay, so let me show you this table to recap. Then this video to recap it so that you see. Then I will now agree with you for those who missed yesterday. Okay, so especially the calculations. If you want me to take you through the calculations, I will be glad to just do that. Okay, or if you want me to send you the video that I made on the calculations. I put together 4 questions, and I'm pretty sure that any of the 4 questions, they can't take it out of that first question. But if you are able to go through those calculations, you will be smiling on Tuesday for your exams. Okay, so just watch this video. Okay, that is your propan 2 ore. That's your sample C. Okay, can you see sample C? Okay, testing it with what? Litmus paper. Okay, testing it with litmus paper. I told you that sample C, okay, with litmus paper is neutral. Now we are putting your potassium dichromate into the tube and adding water. So we are trying to form acidified potassium dichromate. Okay, that orange substance in the tube is your potassium dichromate. Okay, so this is your acidified potassium dichromate. Okay, so this is acidified potassium dichromate. Now, your acidified potassium dichromate plus your alcohol, okay, plus your alcohol. Can you see mixing it together? We'll now try to warm it. This is your oxidation test. Can you see the color? Okay, without even warming it, can you see the color? So if yours is not changing, can you see the color? Can you see? So your acidified potassium dichromate plus your what? Plus your alcohol will change the color to what? Green. Can you see the color is changing? Can you see this color is changing to green, from orange to green? Can you see that? Okay, that's your test for what? Test for alcohol. Test for primary alcohol. Can you see the color will change? That is what you are going to get. Okay, that is the color change that you are going to get. Okay, and that is the last 2F that we did now, 2F, okay? That is what you are going to get, okay, from that, okay? So let's look at another test. Let's look at another test quickly, okay? So you can see the colorless substance. That's your propan 2-O, okay, in your boiling tube. Propan 2-O in your boiling tube, okay? Now we want to add iodine to it. This is your iodoform test, okay? Okay, so let's mix iodine together. Then the next thing will be to add what? Your sodium hydroxide. We'll mix everything together, okay? So your iodoform test, so that's your, like, you know, that's like a methanol. Methanol cannot give iodoform test, okay? You cannot give iodoform test. So now you want to add iodine solution, okay, to each of these, to your propan 2-O and to your methanol. Okay, add iodoform test to that. So it's very important that you are able to observe your change, your color change. So the two important color change here will be your oxidation and iodoform test. Okay, oxidation and iodoform test. Good. Now, so let's see. Okay, so as you're adding your sodium from reddish brown to what? To yellow. For our table here, you can see 2D to what? With sodium. I didn't know I was muted. Okay. Okay. So thank you, Idatu. Okay. So for those who missed yesterday, when do you want us to do a recap? Would you want it now, or for those who missed yesterday? That's what I'm saying. Yesterday's work. When do you want us to do a recap of that? Yes. Or should we go ahead with it now? That is your quantitative what? Quantitative analysis. Quantitative analysis. That of yesterday, for those who missed that. Okay, you can send. Oh, someone said tomorrow. Tomorrow, let's get feedback from others too. Okay. Yes, others, those who missed yesterday. Okay, I think the only person here now who was around yesterday was Sheon, right? Okay, so yeah, so we have done Sheon, we have done qualitative and quantitative. So, but for question one, somebody suggested tomorrow. So let me hear from others. When do you think it's suitable for us to go over your calculations, quantitative analysis? Okay, Fatima said later in the afternoon. Later in the afternoon. Any other person? One is suitable. So I don't know how to marry the two together now. That is tomorrow and later in the afternoon. So okay, or so how do we marry this together now? Coach Adeyemi, are you in? Somebody said tomorrow, somebody said later in the afternoon. So which one do we choose? Which one do we choose? Coach Adeyemi, are you in? Okay. Or would you want me to put? Would you prefer a video recording of the calculations? Would that work? Since some people prefer tomorrow and some prefer this afternoon, so it has to be. I have to choose one. Would you prefer a video recording of the calculations?
Hello, sir.
Hello, sir.
Yeah, please. Because mathematics is on Monday.
Yes.
I will suggest we have it today,
so that they can use Sunday to read.
So that they can use Sunday to concentrate for mathematics. And then after today evening, you can now share the video for people to watch at their leisure.
Okay.
And if there will be any question or any need, they can private chat you so that after mathematics on Monday, if we need to have a last minute rush, last minute stuff, we can just use it to go over questions and areas of concern.
Yeah.
That's my suggestion.
Yes, yes. I think that will be fine. So that's the we may have so that you can use your so that you can use your Sunday to read for maths. Okay. So let's free Sunday. So maybe later in the afternoon today, we'll just like maybe 1 hour, 1.5 hours. I'll just take you through calculations, okay, for your paper 1. Then I will now share the video with you. It is very self-explanatory. I am the one that did the video. So everything I'm going to be explaining is what I've explained in the video, okay? And you can play it over and over, okay? So if you miss this afternoon, you will get the video and it will still be very explanatory, okay, for you. Okay, so when are we meeting this afternoon?
Let us agree on the time.
When are we meeting this afternoon? When? This afternoon, when? 5 p.m., 4 p.m., 6 p.m., when? Put your time, just put in a chat room, quickly. Let's always communicate quickly online because its data is going. Yes, please, Sheon, please. Yes, you can. You can, Sheon. You have completed the course. Yes, Sheon, you can. Yes. Okay. So, yes, please put your time. Okay, 5 p.m. Okay, so I think 5 p.m. carries the day. 5 p.m. then. 5 p.m. exactly 5 p.m. I'll be online and I will start. Even if it's one person, I will start and move on. Okay, so that I can be through with this. It's been some days of for me. Okay, so yeah, 5 p.m. this evening. So go over the notes that you got now. Okay, go over it. Okay, I am going to be sending the by 5 p.m. you are going to be getting the video, okay, and the PowerPoint for this material. Be getting the PowerPoint. Okay, but I want to believe you also took your notes down. Okay, so I'll see you 5 p.m. then. Okay, please don't come
Right,
late.
sir.
Yeah.
Thank you, sir.
Okay, guys, take care.